Hi there, Rithia. Um, Today's plan is PAD test. Uh, I've done some few changes to the code. Uh, the plan is first I've reset everything. Okay, the first thing I've done is copy this, the altimeter. Nadia Akami. And bear with me. Currently, what I'm doing is not really necessary, but it's happening just to ultimate me. Now, everything is set to 111. Okay, yeah, answer this. Other thing, okay, yesterday last night I tried to change this. The PID function of range. I started with 50. This is the range. Apparently, when you are with Bang Bang, okay, with PID temp, how should I start? Okay. By default, Marlin uses Bang Bang. So you set your Bang Bang max. Mine is at 250. This for the extruder. And then this function equates Bang Bang max to PID max, roughly something like this. Gives it that range, and then this is a smoothing factor, like overall amplification factor. Okay, they are calling it smoothing factor. It's not really amplifying. It's okay, not really sure. So originally, this line is commented the PID temp. So Marlin uses Bang Bang, goes to the temperature. You set temperature. If it exceeds the set temperature, it just switches off. When it goes under, it switches off. When it goes up, it switches off. So we are somehow oscillating along the set temperature. Advantages of Bang Bang, it's fast. You're giving it power, full power. This 250. You're giving it your power which you have set, all of it at once. You're not like giving it in steps or something like that. Okay, or it can be in small steps, but getting to there. But my it's like my basic understanding of Bang Bang is just like a switch without a capacitor. Switch it on, you're at full power, and, without now when you come start using PID. With the previous video, I tried explaining the PID values, the PIDs, but I'm gonna just okay. I'm not sure the function for PID for Marlin, the function, but I'll show you the function that I was planning to use for a drone. Which page was it now? But basically PID just means proportional, integral, and derivative. So So you take the first term. When you are getting values from a sensor, you rather create 3 subdivisions from the sensor. The first value is normal, it's just proportional to the set value. The second value is the integral. You integrate the value that you have. The third value is the derivative. It's the difference between the value you have and the previous one. The previous one and the one you have. I think the one you have and the previous one. So after that, you now put some constants against them, against the values. I'm still looking for that page because what I'm explaining is virtually. So once you put the constants, you get to like control the proportional, the integral, and the derivative parts of the values that you're having. So you can't seem to find that video, but I'll look for it slowly. When you'll be watching for the temperatures, I'll look for it. So currently, the constant that I multiply to the proportional, it's 1. Constant to the integral is 1, and the constant to the differential is 1. I've initialized everything to 1 just to see. Now, what you're gonna do is best is to test the previous values. These were the previous values. This one here. I was using the altimeter. So there's some parameters here that I'll check up on them, but I've enabled this PID auto tune menu on the LCD, and then there's this option for sending data to the serial port just in case you're getting errors. I'm still to check up on this because I can't activate my serial ports because front office, or I close front office and it's also it's just a power source. So since as you know, I've removed the diode from the RAM's board, so I can't power from PC. Okay, I can't power from the power supply, not from PC. I'll just disconnect. I think I'll disconnect front office and then start a serial monitor to see if I get values. But I'll do that with time and then come back to you. So these are the PID values, and then the main things and range. After you set your PID values, you set your max power bus, and then there's a PID option for the bed. For the bed now, oh yeah, this is what I was looking for on the 90, the max range. So I think because of the time, because Bang Bang is faster, Marlin is using it's using Bang Bang initially, and then when you get like this to PID functional range, let me get to this PID functional range, like for example, I've set mine, yeah, when I'm PID tuning, I'm setting it to, I try to set it to 200. I got a failure, the temp was too high, so something of this sort. I reduced it to 150. I haven't tried it, but at that time, this was it was at 50. So the values, the problem with this, you can't have a log. There's no log function, or if there is, I haven't seen it. Yet. I'll search on it. So I can't. In short, let's just try. We have set our PID values. I've increased the PID functional range, and then here we go. So let's expect our, if you get errors, get error. Hope we can see the value as well. It's sprinting up. Can just barely fit. So we're at 170. See, auto tune failed, temperature too high. I've passed it by a margin of, we're at 172. So let me pause, because when you check online, when you get this error, it tells you that the PID auto range, you have passed the range, and you see I'm at 150. I'm tuning for 150, and I've pressed set an auto range of 90. It's roughly supposed to go tune up to 240, but it's not. So or we just do it manually. I come here, I put my heaters on, I start with, maybe I'll set for PLA maybe at 150. I'll convert it later, and then we see the fluctuation, because what we want to mitigate at the end of the day, it's fluctuation. It's how it's skipping or something of the sort. Yeah, so let me pause, let me do that. I change on the code, I put it to PLA to 150, because I don't want to, we just do it. It's off. So set off, you can like turn off. Okay, so set on to 10, target 10. We are heating up. These are PID of 1 on everything. I'd like me to come back and analyze this video with its poor quality. We are getting to 10. But you can see it has cut. It has cut. So we have overshoot. Let's see how long it will take. The overshoot is 114. It's taking its time. It has if you are to do things like some really quick prints, I think this temperature adjustment is that time is okay. It has works well with with this. It's not oscillating. It's maintaining. Okay. Remember, you're heating up something and you're not extruding. I don't know if the fan is on. Let me check if the fan is on. Now you go close to it and then you hear a spark. The fan is off. You can't see anything because of the glare. I'm trying to feel if it's hot. I can't feel its heat that much, but there's like a heat. Definitely there's a heat. There's some heat. So let me switch it off. Obviously when you switch off, there's nothing now. It's just watching for the temperature. It has taken quite some time. Okay. It has taken, I might say it has taken a while. So let's do, I can see at 22.7.3. What's the mean of this? 10, 30, 90 divided by 330. So we take this. These are well, may I say, they are common extruders. There's the Ultimaker, there's the Maker gear, and there is the Mendel parts V9 of 12 volts. So obviously I'm using 12 volts, so I think this is what I might be having, close to 63. But since we don't know, let's try. Hope it has cooled down, because you have to check on you're at 150. Let's cool to roughly 50. So let me look for the code for what is it called, fan, for the fan. You just go to Marlin main, and then at the top of the page there's like a commented section where they have the G codes. So not sure what's fan. Let me search for fan and then I'll be back. Let me shut the video. So what I've just done is found one fan, copied it, pasted it on the search, and then it will obviously give me all the occurrences of fan in that section. It's saying there are two fans. Set heat up values for materials on the LCD. Hot end, bed, fan speed, S material, PLA. Set heat up values for materials. Okay, these are already been shown, it's just that we don't have the fan speed. but M145. Let me note that down so we don't come back. And then this is what I do. Roughly, it's not really detailed, but like I have pages for things. Hot end to have its G codes, and then motors. Okay. Not sure. It doesn't have a lot. Just the G codes that have. Where are they? Like these are for the motors. When I was using for the motors, testing lucky. These are for the steppers. So here is one for the hot end page. Now there's a fan page. It says 145. Set heat up values for materials on the LCD. Let me pause. I've noted them down. So let me try this code first. 145. Copy. Since I'm gonna, we'll just find it. Everything is on. Send in. It's taking quite a while. We are at 64. As it sends, I think it has lagged or it has hung. Send print fans, print fan off. I can only turn it off and on or off. The rest are not G codes. I thought like there was like a code, just a code for turning the fan on. Section here. Section entries are good. Okay, let me go to configuration controller fan. Define. Let me check up on the fan and then I'll be back. So there's this. You can have controller fans. A fan specifically for your steppers. I think you can like have 3 of them connected to one port, each for each, or 4, each connected to each stepper. Okay, or attached to each stepper. Let me check for the other one and then you control it through here. Define use controller fan. It's enabled when the steppers just turn on. So I'll continue the search in advanced _config.h. There is an option for a controller fan. As we saw, this controller fan is not necessary for the steppers alone. It's just any other fan, an additional fan. As you will see down here, they've actually, you define it here. It comes with its specs and its speed, seconds. And then, okay, let me check this. And then here, PWM scaling for the fan. So defined my maximum. Let me just define my minimum too. Let's do a 10. 20 will be ideal. Let's do 20. Now for the controller fans, if you have enabled it there, here you assign them pins. You can say auto fan turns on the extruders, temperatures goes above auto fan 10. Extruder cooling fan. So don't tell me I haven't, but my fan is connected to the fan pin. So apparently the fan that's connected, it's according to Marlin, from these lines it's not fully defined, or you can change them. I wonder what will happen to that. Oh, that's if you're using a different setup, maybe an EFF extruder fan or extruder bed. I don't know with their configurations. You can just come change things, yeah. Chamber auto fan pin, extruder auto fan pin. I'll check later if let me pause. I check right now. So yeah, it's connected to an analog pin here. The fan pin is connected to this thermistor. Student servos reset power. Thought I'd checked it well. I don't seem to find. Oh, here. Sorry, this is what I'm looking for. So the first transistor, second one, third one, D10, D9, D8 connected to GND. So D9 in short, and it's a D9. So the fan pin is where is D9? D9. The fan pin is not really analog. So I'm not really sure why am I even controlling this 20 and 240. But okay, I've just set it that. And then if you've connected them to a PWM, that's roughly one of the pins that you'll find in aux 2 or aux 3, because aux 4 is taken. aux 2 or aux 3. Keep forgetting you aren't related to it. So this is aux 2. This is aux 2. This is aux 3. So aux 2 and aux 3, and then D9 for the fan here. It's connected to, when you come here, one of these, the pin will feed into 9, and then these auxiliary pins here, depending on which one it is. Now for the analog ones, they're obviously connected to the analog pins of the Mega. The analog pins of the Mega, these are the analog pins of the Mega. D0 to D13 have PWM, and then these are the analogs. and then the rest are digitals. So it's D8. It's supposed to have PWM. So yeah, it has PWM. Sorry, I've confused the things there. But the D0 to D13, I forgot about it. Has PWM functions. In short, you can set them as a diode, as like a knob. It's like a switch that's like a knob. The rest are just switches, on and off. There's no in between. So you have set that. But if you have extra fans, this is what was. I think okay, but yeah, you get. This is after you have changed your bed configuration from EFB to something else. So you don't have a fan, you come place out your fan here. You can have 5 extruders, 3, 4, 5 here. There's like a chamber fan, there's an extruder auto fan, temperature, extruder auto fan speed. So since I have an extra fan here, I think there's a difference between controller fan, because these fans here, under how they have been commented, it's under extruder, you see. But here there was specifically used controller fan, under controller fan. So for the steppers, and then the pin is obviously is undefined. Okay, so yeah, this makes things easier. When I just see a pin, I know it's something different. It has its own pin, so it's a variable by its own. So this fan, I'll add it. I don't know. I think maybe either I cool the ramps, because it's one. It was actually running out of stock. I found it at $2, roughly $2. If I could have bought enough, I could have cooled, but my steppers aren't heating up at the moment. So yeah, so I think I'll use it to cool the part. I won't cool the ramps board. I'll just have to buy another fan, a smaller fan for the ramps board. I need to remember that. This one is to cool the part after it has been extruded. I saw people say it gives better results after cooling the part, slightly quickening the process of cooling the part. Now yeah, so controller, but specifically this for steppers. They have said steppers, it follows steppers, and then there's extruder. I think there should be another fan, but there's no additional fans, because I've searched fan. The only fan section is here, and here, and this is extra fan speed. Adds a secondary fan speed to each print cooling fan. Oh, but this is speed. Print cooling fan. I hope you don't mind. Let me search for print cooling fan, just so you see if we have just to see if it's already defined, because I might end up using something else. Configuration advanced. All of these are configuration advanced. 47 results in 47. All of them are serve roughly the same. Print cooling fan. Hope it's not light. So okay, there is no. Let's go back to fan. But this is for if you're cooling print cooling fan. So let's go back to fan. So yeah, there's that. Now we can, this thing of obviously by night as of we got an error. So what have I changed? Okay, I've forgotten what I've changed. I forgot. I'm not using auto PID tune. Jibambe bana, takunisumbua. Let's hit up. It's disconnected, so we connect. And we at least right now I have a function for the fan. I can turn on the fan and turn off the fan. Then we first paste it so that just in case it's ready. Almost 6. So 106 is to turn on the fan. Okay, nothing is working. Should I disconnect and then switch off and then, or is it standard? Oh, earlier it was making a loud noise. It's cool now. So here we go. The fan is on. It's roughly at 240. Okay, I haven't uploaded. Okay, I haven't uploaded the code, so you'll have to switch it off. Oh, it's as if it's picking up speed over time. Okay. Okay. Just a house view. So switched off. Let's try. I want to keep entangling myself. We didn't alter this. Oh, we altered this. So yeah, let's just upload. We disconnect before it gets to the. I'll be back. I'll pause when it's done. It's done uploading, so we connect. The printer currently is dark, so let's just focus on the screen. So we go. I think I should turn this thing on. I'll turn the fan on when you want to cool. You're getting to 210. I might say we have roughly improved the time because these steps look slightly bigger. So there's an overshoot, a slight overshoot. Okay, slight is an understatement. And we are continuing to 50. If it continues, that's just proportional. The max time for this thing, I don't know, it was what? Let me check again. It was, I think, 280 something. After that it burns out. So after I've added up on proportional, we are going there slightly faster, but the overshoot is big, and then it's not stable. With ones we maintained to 10 roughly more constantly. There's like a oscillation, so whether that's proportional, I don't know. Integral is just like a proportional, so I think I should leave it at 1. It's just a bigger form of proportional. It's big or small, I'm not sure, but it's roughly, it's just like a cascade form of proportional, or a square rooted, not a square, a powered, what do you say, factor, not a factor, it's a factor, whichever. Okay, so we go back. Sorry, myself. So we now check for, and as you see from here, there's a K1 for altimeter, there's a 0.01 for maker gear, and there's a 2. So that's a 0 plus 1, 3, 1. 1 is good for proportional. For integral, man. Derivative, let me take another mean. So we have 440, 10. So this becomes 130 plus 440. So we make it a 60, 160 becomes 540, 600 divided by 3, 200. Sorry, I'm slow. Got it used to a calculator over time. Copy. Paste. Okay, now I think once we get these values, we can roughly get close to PID tuning our own controller, auto PID tuning actually. So yeah, these are our new values: 30, 1, 200. So we disconnect, we upload, and then I'll get back to you when it's now. So it has uploaded. Sorry, you can't see down here, but let's stay up. Go back to front surface. Don't know if you can see. You might have to squint, but at the moment, if you're seeing this window, you roughly know the various controls and components. But mostly, what you are interested in is this or this here. You just double click this, it gives you this. And what else I can double click? This can't be double click. This can't be double click. Check temp is a command. M10. So this is an M105. So we are still cooling down. Let me hasten the cooling. Forgot to actually start cooling. Where do you see a 6? Because I can't seem to find M106. Here's a 6. So the fan is on. It has, let's see, this is a drop. The drops are becoming shorter. I wonder, obviously can't wait for the installation of this. You can't see that thing, but yeah, it's a water cooled. It's a water cooled hot end X here, and it's small. It's in the previous videos. I've actually can't really say a review. Just run it. That lighting, my lighting is just not doing justice. What I mean. As you know, we are waiting for this thing to cool, so we are under 100. We wait up to 50. 50 seems right. Let me pause. Let's just watch the cooling. So I hope this graph will be larger so that gives better results. I wish you could just have a login function. Sana for the temperatures necessary. And once one installs some encoders to their steppers, I think they might want to use serial a lot. That's for front surface, not on Marlin's end. Marlin has a, rather you just, if you need login, you just code it for yourself. Or you can install a Wi-Fi module. I'm not sure if the serial ports, it allows 2 port communications, but I think it's roughly a copy. I don't think it has. I will install I have a Wi-Fi chip somewhere. I'll install it with time, but let me first get to print at least some few things, maybe 2 or 3, and then think of installing a Wi-Fi module for how should I call it, offline prints, for when I'm offline, when I'm not around the printer prints. We're at 64. I don't really think that fan is helping a lot, because that gap, the heat transfer from the hot end, this gap here, because this one is attached to this one, this gap here, I don't really think it's passing a lot of So we are at 54. We can actually start eating. That's just enough. So what we were looking at was how fast we are getting to temperature. Let me not cover this 54. So we didn't even search it off. Yeah, it was off because there's no target temperature. So let's go. The fan is on. Previously we had a big overshoot. Steps proportionality. It's going in steps of 124, 8, roughly 8. 8, 7, 9, 10. 10 to 6. Mostly 8. Almost getting to target temp. It has started to flatten off. It's a big flat off. Yep. Let's see the overshoot. I'm not really expecting a big overshoot. So 212. Derivative takes care of overshoots. Rather sudden changes. That was the term. I'm not sure if now I'm supposed to add the derivative first here or the integral. I didn't want to add the integral because we overshot. We reached to 70, and I think this thing burns out at 290 something. So yep, we haven't passed to 220. That's a good sign. Maximum was 214 to 15. It's leveling off slowly. So we need that integral 0.1. We try. But at the moment I will say, because I'm at 210 strong, you can roughly print. That's a constant temperature. It's just that it's taking long to adjust. I'm sure it's a proportional thing, so both proportional and integral will help me. But apparently I feel lazy to change the code. I'm seeing some good results here, so let's just okay. Yeah, let me work with this. This is what I have. $31,200. So I think I might end up following these Mendel paths. Now what? For me to get better results, I'll just have to use my Casio. Yeah. And I don't know why the lighting is that badly off. I wiped the camera yesterday. I might let me try. AMOLED things, Okay, I wish my screen was AMOLED. I just increased the glare. But it's a good sunny day. Can't complain. I'm not gonna complain. Yep. 209, 210, 210, 210, 210. So This is what we're looking at. The results look good. I wonder how these guys were getting like point. You know, this guy got to once, tens, one tenth. It was, I think it was one. Yeah, he got it to the 10th. That's okay. Yeah, I think that's auto tuning maybe. Because from what I might say, we're still at 210. Should we switch off the fan? We see if it has an apparent effect on the heating. Let me look for a 7, just to see if there's like a spike. Let me prepare the other graph for better results. I think I should search for a day that I just heat up my hot end and my bed. I'm really skeptical about the bed, heating up the bed. I feel I might have like a failure. I was looking for a 7. Okay, so we'll try. So the hot end is almost isolated from it. Has even cooled down. It has gone to 29. I wish I had my PWM values. There's like a code you saw me using in the now this is what happened. There's this code. I was using it I'll upload it. If you comment for each one to code. I was planning to put it on GitHub. But, yeah. It's just like a simple code. It was doing switching on and off. But the good thing with it, I was getting a readings of my proportional. Once I do the proportional and then multiply by the constant, I was getting it as a value. My integral, once I integrate and multiply it by its constant, I get the value. And the derivative, it was just giving me, this was for analysis, because at one time, sometimes, machines are just machines. So at times there can be an error. So there was something, I'd done a mistake in the millis, and the other time I re-uploaded the code, I got different results. So but okay, it's roughly consistent. It's just like a one-time thing. So yeah, got my functions here, and then dx dt, this was used for derivative. I was looking for the formulas. I can just show you the formulas through the code.